Resolving software configuration issues. The theme for this nugget deals with how do we as desktop support technicians and IT managers enable legacy software or software that was published prior to the introduction of Windows 7 to work properly under this new operating system. Microsoft learned a lot in this department through failures in the previous version of Windows, Windows Vista, and we're going to build upon those skills and I'll show you how they apply to 7. First, we have a Microsoft exam objective that they call enabling and disabling features, although that's not exactly what we're doing. You might think that this deals with Windows built-in features, but no, what we're going to be dealing with are the various and sundry application compatibility modes that we can use to help make a troublesome application function under Windows 7. In the second bullet point, we'll deal with a free download from Microsoft called the Application Compatibility Toolkit, or ACT, and we'll learn the basics of how to use the ACT toolkit to develop what Microsoft calls application shims. These are specific fixes to specific troublesome applications. Finally, we'll review something you're probably already well familiar with, and that is, if we do have applications that are coming down from a file server, how do we make a client connection to that network resource? Without any further ado, let's get to work. It stands to reason that any new version of Windows is going to involve compatibility issues with what are called legacy applications. Now, legacy is an IT buzzword that you're probably familiar with that means old or older. And of course, that term old is relative in information technology. It can refer to a 2-year-old application. Accordingly, we have a series of tools that involve compatibility with those applications that aren't able to seamlessly migrate, so to speak, in a Windows 7 environment. So this deals with application compatibility, which in a Microsoft schema involves invoking features of down-level operating systems, such as perhaps even as recent as Windows Vista, but more likely we're dealing with older applications that functioned fine under, say, Windows XP Service Pack 2, but once you make that upgrade from XP to Windows 7, the application just doesn't work anymore. One website I want you to be aware of is called the Windows 7 Compatibility Center. Here it is right here, as a matter of fact. The Windows 7 Compatibility Center website has a really long honkin' URL. Therefore, my suggestion to you is simply to run a Google or Bing search for the phrase Windows 7 Compatibility Center, and it'll take you right here. In my opinion, this is a nicely laid out website that is, as Microsoft says, is a place to see what works, get drivers, updates, and downloads. So anyway, this isn't going to be covered specifically on the exam. I just wanted to give it to you as a professional courtesy. Back to our whiteboard and the stuff that is going to be on the exam. The basic approaches to troubleshooting application compatibility in Windows 7 that we're going to cover include the following. First, we have the Program Compatibility Troubleshooter, which is a direct descendant of tools that were introduced in Windows Vista. We'll then look again at a technique that was around in Windows Vista and has just been refined quite a bit in Windows 7, where we can customize the properties sheet of an application and manually set a compatibility mode. Third, from an administration standpoint, we have group policy options that customize or tweak how application compatibility works on the desktop. And then we'll look at a really interesting feature, brand new to Windows 7, called Windows XP mode. Hang on to your hats for that. I think you'll enjoy that. Traditional methods for application compatibility. In Windows 7, we have this new tool called the Program Compatibility Troubleshooter, and this might be your first line of defense when you're troubleshooting an application that used to work in a previous version of Windows, but now isn't working at all, or perhaps isn't working fully, is kind of working in Windows 7. Now, the compatibility troubleshooter's been around for a couple versions of Windows now, and traditionally what you had is a wizard-based interface that effectively gave you a candy-coded front end to accessing the built-in application compatibility modes in the OS. As you'd expect, Windows 7 kicks things up a few notches. The Program Compatibility Troubleshooter is a wizard-based interface that hides some of the technical details from you, the technician, or the end user who runs this tool, by giving you not only the candy-coded front end, the wizard interface, but also it deals with automation. It's actually a scanner that will scan your computer for troublesome applications and automatically make compatibility mode suggestions based upon what it finds. So as a DST, you may want to start with this, or you may just want to go directly into accessing one of the built-in application compatibility modes supported by Windows Vista. And remember, the notion of the compatibility mode is where you're assigning the application a context, an execution context, that emulates a previous version of Windows. Now you see here that Windows 7 gives us a tremendous amount of flexibility in compatibility mode profiles. You can go as far back as Windows 95, banish the thought, Windows 98. There's actually, and this is, I wonder if it's an inside joke on Microsoft's part, but there's a Windows Millennium Edition compatibility mode. Imagine an application that functioned on ME but doesn't work on Windows 7. That's something to ponder. Windows NT 4.0 Service Pack 5, Windows 2000. Note that we have XP Service Pack 2 and Service Pack 3 profiles. And even as recent, although this is very unlikely that you would have an application that functions well in Vista but does not function in Windows 7, Microsoft decided to hedge their bets and give you 3 compatibility modes for Vista. Vista RTM, or release to manufacturing, just the gold version, Vista Service Pack 1, and Vista Service Pack 2. Now, you can also, and if you've worked with application compatibility modes before, you're aware of this, besides emulating a previous operating system, you can also cut down some of the graphical bling to reduce those issues. I mean, you may have some line of business applications that, let's just face it, are old, that worked fine under Windows 95 or Windows NT, and you're still using them in your organization. And you have to make some concessions. For instance, those applications may never have been written to support the visual themes, say the arrow, glass effects, and so on. Maybe those applications were hard-coded to run with an administrator token. Well, we know that as of Windows Vista, and certainly with Windows 7, even local administrators or domain administrators run with a standard user token by default. And then we have colors and resolution problems as well. So we can cut down the color to 256, which is pretty amazingly low when you think about it. That's standard old-school VGA resolution, 640 by 480 resolution, and we can even force the application to run with the administrator token. Of course, the hazard here is if your local user is not an administrator on that machine, they won't be able to run the application. For the 7685 exam, as well as in your professional lives as DSTs, you should be aware that there exist application compatibility settings in Group Policy on Windows Server 2008 R2 and in Windows 7. The path to those policies is Computer Configuration, Application Templates, System, Troubleshooting and Diagnostics, Application Compatibility Diagnostics, which you see in the screenshot here. I'm not going to spend a lot of time on these here because in the upcoming demo we're actually going to take a look at the details of these policies. But to get the general flavor, you notice that we can specify to notify on blocked drivers, detect application install failures, detect app failures caused by deprecated Windows DLLs or deprecated COM objects, detect application installers that need to run as an administrator, and so on. So these can be helpful, if not just from a management standpoint, but also from an application troubleshooting and reporting standpoint as well. Before we discuss Windows XP mode, let's spend a moment to review what we've discussed thus far with regard to compatibility options. First, we have that troubleshooter. Second line of defense, we have modifying the properties of the executable to specify a compatibility mode manually. Third, there's the notion of group policy. And now, what we might want to consider a last or final line of defense if none of the previous techniques work to get that down-level application working. Microsoft has given us this new feature in Windows 7 called Windows XP mode. Now, Windows XP mode allows you to run your legacy applications in an honest-to-goodness Windows XP Professional Service Pack 3 environment. Understanding XP mode requires that you know a little bit about virtualization. Virtualization involves you installing and managing virtual PCs or virtual computers. Virtualization refers to the abstraction of hardware resources. In other words, you're implementing a computer, an installed operating system with virtual RAM, virtual processor, virtual hard drive. You're implementing that operating system and that virtual PC in software. The subject of virtualization as a whole is beyond our scope, It's certainly worth your while to do a Google search and read about it. One application that's available for the creation and management of these so-called virtual machines is a Microsoft product called Virtual PC. Microsoft actually has a couple different virtualization products. Virtual PC is their desktop edition, and then they have Virtual Server, and then the entire Hyper-V technology for server virtualization. Alright, enough background on that. Windows XP Mode, in essence, is a free download. It does not come shipped with Windows 7, in which you install a special version of Virtual PC, as well as a virtual hard drive file, or .vhd file, of an already installed and configured Windows XP Service Pack 3 OS. Now, let me come down to the very bottom under System Requirements. Before you get too excited about this, remember Windows XP Mode is intended to remediate software configuration problems, and it's intended as a last line of defense where you have line of business apps that worked fine, say, in XP, but just no matter how hard you try will not work under 7. Accordingly, because this is a business-based remediation technology, notice that Windows XP Mode is available only for the Professional, Enterprise, and Ultimate editions of Windows 7. You can't get Windows XP Mode for a Home edition, for instance. Now, once you've gone through the installation of this free download, and I'm going to show you how that works in just a minute, you can actually install applications under Windows XP just as if that XP installation were your actual hardware computer. And your applications that are installed in the VHD appear in your Windows 7 Start menu. So you have a virtualized application environment. It's really quite elegant and quite cool. Again, it's a free download. You don't need to worry about a product ID or a product key for the Windows 7 installation. As long as you have a legal activated version of Windows 7, the virtual hard drive image works just fine. The system requirements are pretty steep. You have to make sure that the computer that's going to run Windows XP Mode has a CPU that supports the hardware virtualization extensions. Now you can check that out in various ways. You can check the system BIOS, or there's plenty of free downloadable tools that you can run that'll tell you whether your system does support this. Hardware virtualization enables a tighter coupling between the hardware on your host computer, your actual hardware, and the guest virtual machine, which in this case is your Windows XP Virtual PC. Also, Microsoft suggests having at least 2 gigabytes of hardware RAM on your host PC, because the whole deal with virtualization is that the virtual or software PC, it gets its RAM from the host. It gets its disk space from the host. It gets its CPU from the host, so you get the idea. You need to make sure you have more than enough RAM to run Windows 7 normally, which is at least 1 gig on your host, and then you need to give almost a gig to that guest. So again, you have some fairly stiff system requirements here, but as long as you meet those requirements, you're good to go. Now I'm going to give you a slideshow demo of how to install and use Windows XP Mode. After you've verified your system requirements, what you'll want to do is hit up Microsoft.com and download Windows XP Mode. They have a little picker here where you can choose your edition and language to make sure that you pass muster there, and then you download the Windows XP Mode, which is actually the VHD drive, the hard drive, which is maybe 500-600 megabytes. And then second, you have the Windows Virtual PC, which is, if memory serves, a little under 10 megabytes. It's pretty quick. So you have to download and install both of those packages. After you've done that and you've run the installer, you wind up on the front end of things with a new program folder in your Start menu called Windows Virtual PC, and you have an option to start the Virtual PC console itself, and then what we're interested in, an icon for Windows XP Mode. Below, this is just showing that when you're installing Windows XP Mode, going through the setup, you specify the installation folder, no surprise there, and you create credentials. Note that you run an XP Mode in your virtualized Windows XP SP3 session as a user, a Windows user called XPM user. And you want to make sure to choose a strong password for that user. Once you've installed and started up Windows XP Mode, what you're seeing here is the Virtual PC console running on my Windows 7 host. and you notice that the XP mode runs as a task on your superbar, no big surprise there. But other than that, you notice that the Windows XP desktop is identical to what you'd see in a hardware situation. That's because a virtual machine is exactly the same as a physical computer, except that its hardware is implemented in software. And this XP mode guest can get out onto the internet. You can fire up IE version 6, get out onto the web and download and install your line of business software. Actually, you wouldn't go out onto the web for that, chances are. You'd hit a local file server. You're doing that masquerading as the credentials again on your host. When you shut down the Windows XP mode, notice that Windows actually hibernates the virtual machine instead of shutting it. Of course, the reason for that is to make startup the next time a lot faster. The bottom screenshot shows what I've done. In the Windows XP mode instance, I've downloaded and installed the trial version of WinZip. And you notice that now, without Windows XP mode running at all, I can simply open the Windows 7 Start menu, expand Windows XP mode applications, and then click that shortcut to start a virtualized instance of only that application. And that's what we see here. Notice that we're not seeing the entire Windows XP mode console. We're seeing just the virtualized WinZip application running in Windows 7. Pretty cool, huh? You might be thinking, are there any downsides? The big downside is just overhead. The fact that to bring up Windows XP mode is going to involve a significant RAM footprint, as well as the RAM footprint of any virtualized applications that you're running. WinZip is a low horsepower app. On the other hand, your line of business app might involve quite a bit more in terms of CPU, disk, network, and memory. All right? In this first demo, we're going to spend some time looking at the application compatibility options in Windows 7 in living color. We'll start with the program compatibility troubleshooter, then we'll review how to adjust the properties of a troublesome application, and finally we'll fire up group policy and we'll take a closer look at the application compatibility related group policy object settings. Let's get rocking. In this demo, we're going to look at application compatibility options. We're on a Windows 7 domain member called WinNugget, and I'm logged on as a domain administrator named Trainer. Now, the first thing I want to show you is that the application compatibility options are available only for software that you install that aren't a part of the default build in Windows 7. And I can prove that to you by right-clicking in the Start menu, a built-in program like Solitaire. We don't see anything related to compatibility here. If we actually drill into the Start menu and I say pick Windows Media Center, right-click, again, we don't see any compatibility options, and even if we view the Properties sheet and navigate to the Compatibility tab, you notice that we can't change this, and Windows tells us compatibility modes cannot be set on this program because it is part of Windows. And that makes sense logically because Windows programs that ship with Windows obviously should be compatible, at least they better be. Now, for software that you install, for instance, if I navigate into Microsoft Office, we have our Office 2007 apps that I've installed. Of course, we shouldn't have any compatibility here, but just as a demo, let's assume that we do have some compatibility issues. One thing we can do is right-click on the program shortcut and select Troubleshoot Compatibility. Alternatively, you can do this on the raw executable. It doesn't have to be the shortcut. I just want to demonstrate that right-clicking here, we have that Troubleshoot Compatibility option here as well. So let me come back to that shortcut, right-click, select Troubleshoot Compatibility, and that pops open that Program Compatibility wizard that we talked about earlier. Notice that Windows is trying to automatically detect any issues that it might find in that executable. And then we have the ability to try recommended settings that the wizard selects, or we can choose to troubleshoot the program, and it just navigates through here. You can actually send those results to Microsoft directly if your Windows 7 machine has a connection to the internet, and so on. We'll just bail out of this now. I personally tend to not like wizards as a general rule because I'm not a beginning user anymore. That's one thing. And number two, wizards tend to hide details from us administrators. So a more direct approach may be to find that problematic shortcut or executable program file, right-click, select Properties, and navigate to the Compatibility tab. Again, just to prove that we can do that, you can find the raw executable. This time I'll pick on PowerPoint. Right-click, go to Properties, and again, we have access to the compatibility mode settings there as well. As previously discussed, you can choose a compatibility mode based on a down-level Windows version from 95 all the way up to Windows Vista Service Pack 2. In addition, we can select these options to run in a decreased color palette, disable visual themes, etc. And we can even force the user access token from standard user to administrator. Now you'll note the UAC shield here that you can optionally change the settings not just for the currently logged on user profile, but all of the users of this system. Now then, I've clicked OK such that if I fire up that application now, it's going to launch in compatibility mode. Because I requested that this application run as an administrator, I'm getting the user account control prompt. Now, because I am logged on as a domain administrator, my domain administrator account is a member of the local administrators group of WinNugget by default. That's how Windows works. Therefore, I'm prompted only for consent and not for credentials. So Word is being forced open in Windows 95 mode, and not having too good of a time of it at that. What's kind of funny in a way is that we normally use these application compatibility modes to get a down-level application working in the current version of Windows. What I did is try to force a brand new application to run in Windows 95 mode, and as you see, it actually crashed. This is an educational moment because we see that the Windows diagnostic utility is popping up and allowing us to check for a solution, close the program, view problem details, and we see we had an application hang. And if we click Solve the Problem, Windows Diagnostics tries to find a solution for that crash and will give us back some information. Now let's check out group policy. On this machine, we'll look at local group policy to find those application compatibility settings. In the search box, you can type gpedit, and this gives us access to the Group Policy Editor MMC console. I'm going to right-click and choose Run as Administrator to make sure I'm launching the tool with administrative access. And then we'll drill into Computer Configuration, Administrative Templates, System, Troubleshooting and Diagnostics, Application Compatibility Diagnostics. And a nice feature of this latest version of Microsoft Management Console, version 3 in Windows 7 and Windows Server 2008, is that we can turn on or turn off either the action pane, which is that third pane hidden by default in the local group policy editor, and what I'm going to do now is hide the console tree to give us better access to these policies. Some of these policies can be nice as far as automating administrator intervention with problematic software. For instance, this policy, detect applications unable to launch installers under UAC. It makes sense that any software product that was developed prior to Windows Vista would not be aware of some of the UA-specific application programming interfaces. So this tells us in the very helpful description that if we enable this policy setting, which we can do here, we can then set a scenario execution level, detection and troubleshooting only, or we can actually try to automatically resolve the problem. It says that the Program Compatibility Assistant detects programs that failed to launch, and when a failure is detected, if we choose resolution here, the PCI will automatically kick into an elevated compatibility mode that enables the program to successfully launch the installer with administrative privileges. Again, the idea behind these is an alerting mechanism for you as an administrator and as a way to potentially automate the remediation of problematic software in Windows 7 domains. ACT and application shims. You can expect to see a little bit of content on your 7685 exam dealing with the subject of application shims. However, we do not, and I repeat, do not have to know all the gory details of the ACT as we would, for instance, if we were studying Windows 7 deployment specifically. Now then, the subject matter at hand. As previously stated, the Application Compatibility Toolkit, or ACT, is a free download from Microsoft that consists of 3 main utilities. The purpose of ACT is given in its name, of course, Application Compatibility. The Application Compatibility Manager application is a scanner, really, at least it starts off as a scanner, where you can collect data about installed applications. Therefore, we would run this tool on a reference computer and then analyze those applications in the hopes of connecting with perhaps the rest of the ACT community online, because Microsoft has actually created a community of IT professionals in order to put their heads together and solve some of these app compatibility problems with Windows 7. And then what we're concerned with is the bookend application, Compatibility Administrator. This is where you can actually develop and deploy fixes for applications that break under Windows 7. So Compatibility Manager is our analysis tool. Compatibility Administrator is our fix deployment tool. And speaking of fix, the term shim, which you're likely to see on your exam, means nothing else but an application-specific fix. Maybe an application breaks because there's some issue in a call between a .exe and a .dll. So the shim might replace the exe, might replace the DLL, and give you a third file, and that collection of 3 files constitutes a shim that enables that troublesome application to run under Windows 7. Believe me, Microsoft got a lot of mileage out of the ACT with Windows Vista. There were so many application compatibility problems there. Therefore, the latest version of ACT that functions with Windows 7 carries on that tradition. The third tool that ships with the application compatibility toolkit is called the Internet Explorer Compatibility Test tool. And this is a tool that's potentially useful not only to IT managers and desktop support technicians, but also to web developers, content developers, and application programmers. The IE Compatibility Test tool is used to verify site functionality under the latest and greatest version of Microsoft Internet Explorer, which, as of this recording, is version 8. Final subject in this nugget before we do our second demo deals with pointing to a network resource. This is probably review for you, but nonetheless, in the name of covering each and every exam objective and making sure that you're 100% covered, let's get rockin'. The deal is here, or the scenario I should say, is that we have an application installation package up on our server, and instead of carrying a thumb drive or a CD or a DVD to all of the workstations on which we want to install that software, it makes sense to put the installer files on a central share point and then connect and download those files on each computer in turn. That's still kind of old school, but it's done all the time. Now you need to know, if you don't already, about Universal Naming Convention paths, or UNC paths. Universal because you'll note that the leading whack or // does not refer to a local drive letter. Of course, local directory paths start, for instance, with C:\/ D:\/ That doesn't work when we're dealing with a server resource, obviously, because a discrete drive letter is going to be mapped to the local operating system, right? So UNC takes the syntax of // server name, and then optionally / the share name, the name that you've published that shared folder as. Various ways to access a server-based shared resource include the following: opening up the run prompt and just typing the UNC path directly, browsing through the graphical network control panel, formerly called My Network Places, even more formally called Network Neighborhood. Do any of you go back that far with Windows? Do you remember Network Neighborhood? My preference, of course, is the fastest way, which typically involves a run prompt with a UNC path. If you need a persistent connection to that shared point, you can do a drive mapping, which associates one of the local drive letters on the local machine to that UNC path. That can be especially helpful for old software that doesn't acknowledge or can't work with UNC paths and needs to be installed from a discrete local drive letter. So we could map drive X, let's say, to that SharePoint. Second point that Microsoft wants you to know about connecting to a network resource is that distributed file system exists, DFS. Now, the mechanics of actually deploying DFS is a server-side subject that's reserved for our Windows Server 2008 CBT Nuggets courses. Here we're looking at the client perspective, or the user's perspective, of DFS. In a nutshell, distributed file system enables you to set up, again, the idea of the central share point, or the DFS root share, which would be part of the UNC path. So if we deployed a DFS where the root was called root, users would connect to /server /root. Actually, in a domain, it's a little bit different from that, but you get the general idea. And what's different about DFS as opposed to just publishing traditional shared folders is that these DFS links, or these subsequent shared folders, do not and often are not located on the same file system as the server that's publishing the tree, the DFS tree as it's called. Isn't that nice? Whereas in a traditional file sharing scenario in business, users can get confused all too easily in terms of where do I go to get this shared folder, where do I go to get that shared folder, and it turns into a mess. DFS enables an administrator to aggregate or collect those shared folders that exist likely under wonky names on different servers, put them under a single unified file system or virtual file system, and the user can connect to the root and easily browse to the appropriate share. That's the bottom line with this. Now you access the DFS tree the same way you would access any UNC path from the client. In our second demonstration, we're going to look at the Application Compatibility Toolkit, specifically the Application Compatibility Administrator, and how to develop and deploy a shim. We'll then spend just a few moments on pointing to network resources. In this demonstration, I'm going to show you a little bit about Application Compatibility Toolkit, shims, and then pointing to network resources. Now, what I've done in the background here, I'm on DC Nugget, this is a Windows Server 2008 domain controller, is that I've downloaded the Microsoft Application Compatibility Toolkit version 5.5. This is the latest version as of this recording in February 2010. Remember that the main tools here are Application Compatibility Manager, Compatibility Administrator, and the Internet Explorer Compatibility Test Tool. Actually, there are a couple other ones that are pretty cool. For instance, the Standard User Analyzer enables you to see whether applications that you're planning to migrate to Windows 7 platforms will have problems running under a Standard User UAC token. Now, we're concerned with shims with the Compatibility Administrator tool, so we're just going to fire that open directly. And remember, I'm giving you just a thumbnail sketch here so you know the basic mechanisms for deploying a shim. We're not dealing with deployment so much in this exam. You just need to know the basics. Now, Compatibility Administrator has a built-in database of tons of applications, many of them games, so they're not really relevant in business, that Microsoft has identified as having compatibility problems, at least when Windows 7 was installed. You'll notice we have, like I said, a lot of games, Jane, Hunter and Killer, $100,000 Pyramid, but you also find some business applications as well. Some graphic arts utilities like AC/DC, and so on. And when you click an application, you can see compatibility fixes that have already been created. These are shims that have been created by Microsoft directly. Now you can get into this and access the database. You can run searches against the database to find a shim. That can save yourself some work. You can go online and get hooked up with other administrators and share shims with each other. Compatibility fixes is simply a database of those fixes that are associated with applications. We also have tons of built-in compatibility modes that are oftentimes used in combination with a compatibility fix. For instance, 640 by 480 obviously will force that screen resolution for the fix you're developing. 256 color forces the 8-bit color as well as disabling graphical themes. The idea here is that you can use these compatibility modes and fixes as building blocks when you're developing your application shim. Finally, we have custom databases. You build a database for each fix that you're deploying. So by default, when we open up Compatibility Administrator, we get a blank database here, and then we can click Fix to launch the application fix wizard. Now, choose the name of the program to be fixed. I'm going to choose Demo App, and we can supply a vendor for that application. This is primarily for our use, and then we browse out to where the application exists. Best case, you have the application already installed, so you can get to the exe file. You notice that in the Compatibility Toolkit Compatibility Administrator subfolder, Microsoft gives us a demo app that we can use for testing. Now, when you're creating your fix here, you'll transparently have access to some of these other items that I showed you, like the compatibility mode modules. We can, for instance, force the demo app to run in a down-level version of Windows. Notice it's not as robust as what we saw in the Windows 7 interface, but it's still pretty good. Let's just choose XP Service Pack 2 here. And again, you can choose compatibility modes like cutting down the color, changing the screen resolution, Lots and lots of these to choose from. It's beyond our scope to describe them all, but some of them you recall from our earlier discussion. Run as admin. And you can always do a test run of the application by clicking in the lower right, and that's going to test run the application. You can pass command line parameters if you want, and then in this case it works. The application is for demo purposes. It's not a functional app. Now I don't know if you can see the granularity here. This is telling me that we are in fact running this demo app in a compatibility mode. You wouldn't necessarily know that we're in Windows XP, but you can certainly see that we're down to 256 colors here. This is a very washed out bitmap. You can see the granulation on the installer. Actually, this program, it looks like, requires Windows 95 mode, so we can come back and set the mode for the demo app to 95, and if we wanted to, do a test run. But what I'm going to do is click Next, and this gives us suggested compatibility fixes. We can just show the selected ones. Again, we can do a test run if we want to. These compatibility fixes are associated with the Windows 95 operating system mode. So the idea as a DST is that you want to emulate the most recent version of Windows in its environment that supports your application. Click Next. There's some additional metadata that was picked up from the executable. You can make the appropriate choices here, and then click Finish, and what you see at the end of the day is an application entry much like the built-in ones, but you've created this yourself. And then our shim contents over here specify that when we launch demoapp.exe, it's going to set the compatibility mode to Windows 95. It's going to run at elevated, 256 color, and this is the metadata to make sure that we're patching the correct file. Final step of deploying the shim is to save the package. So we can select it, go to File, Save, give the database a name. Makes sense to name it with the application shim, demo app, and then it prompts us for a save location. I'm going to browse folders, go to the desktop, and I'll call this demo app. And it's saved as an app-compat database or .sdb file. If you've used the Windows Server security templates, then you're already familiar with that database format file. Let's click Save, and you've got yourself a package now that you can deploy either on the command line or you can install it directly. You can install it directly by right-clicking and choosing Install from the Compatibility Administrator. Alternatively, to apply this to one of your production workstations, maybe you would apply it on a reference workstation and then use disk duplication software to do the rest. What you would do there is, first of all, fire up an administrative command prompt, and then we would run the sdb inst command. We can get command line help by running sdb inst with /?. And basically you're just running sdb inst and then passing in the path to your SDB. There you go. Now you know how to deploy shims that are created with the Compatibility Administrator tool. Let's complete this demo with a quick review on how to point or connect to network-based resources. This ties into what we're discussing in this nugget because we can imagine that we're deploying software from over the network. Now, different ways to access resources on our local domain controller. Behind the scenes, I've shared out a folder on DC Nugget and shared the folder under the name Tools. We can Control R to expose the run prompt. Actually, that's a Windows key R, and use a universal naming convention path. If you don't know the share name on the target server, you can just do whack DC Nugget in this case, and that'll display all of the shares that we have privilege to. I'm logged on as a domain administrator. I have plenty of flexibility here. We've got Tools. This is the manually created share. Sysvol and netlogon are both auto-created shares with Active Directory. If I go into Tools, I can navigate in here, and whatever my level of privilege is to these applications, I've got it. Let's see if I can fire up the sysinternals tool auto-logon from over the network. Gives us a security warning. Are you sure you want to install this? It has been published and signed by Microsoft. That's cool. And let me show you that. Notice how Windows is able to run that validation check on the digital signature attached to this code. In a previous nugget, we talked more about code signing. Let's click Run, and sure enough, the application functions. You have to have at least read permission to execute code like this from over the network. Another thing we can do is open up Start, and if we have the network option available, which it looks like we don't, we can select it. Type network in the search box, and we get lots and lots of options, including the network program. This was the original version of Network Neighborhood in Windows NT and Windows 9X. tells us that network discovery is turned off by default. We can turn that on in order to expose network resources. And as soon as we turn on auto discovery, we've got DC Nugget, and then we have our tools folder. Final thing I want to show you is the drive mapping deal, which is most effectively done, in my humble opinion, from the command prompt. We'll open up an elevated prompt by right-clicking and selecting Run as Administrator. And we're going to use a command called netuse. And you can use a star if you're not fussy about the drive letter that's used. And Windows will just find the next available drive letter. Otherwise, you can specify. For tools, let's say we want to use drive T, and then we'll specify the universal path, universal naming convention path to that resource. Now, netuse /?. The /persistent is a good idea if you want the drive mapping to persist over server reboots. And then to finish up, we can switch to drive T, run a directory listing, and we can access those shared resources, whether they be installers or document files or whatever, either through Windows Explorer or the command prompt environment by browsing to drive T. Easy peasy. Resolving software configuration issues review. In this nugget, we led off with a detailed description of the various compatibility modes offered by Microsoft in support of Windows 7. We saw the troubleshooter, we saw the shortcut method of specifying application compatibility modes, we looked at group policy, and then we spent some time with that nifty new Windows XP mode feature. After that discussion, we moved on to the ACT. I hope you now understand exactly what a shim is, how and why they're used, and how we can use the Application Compatibility Administrator tool to actually work with shims. And then we finished with a flourish by reviewing some methods to connect to a central SharePoint to deploy software from a network location. I hope that this has been informative for you, and I'd like to thank you.